So we've learned about all these primitive types, which are very important in Java. Now it's time for us to learn about basic operations, right? So how to add, subtract, and do all sort of things. Now it's not that difficult to actually grasp these ideas. So what I'm going to do is still in the same my class Java here, because we're just getting our feet wet here, as we always say. I'm going to go ahead and let's comment all of this out. So to comment things out here, you can go ahead and say command and / like that, and it comments everything in this file, right? Of course, we're going to have problems with system.out here. I'm going to also comment that one out there, okay? So this is your commenting out one line with these two / But say you want to comment out a lot of lines, what you end up doing is you say / and you put asterisk and hit enter. And the moment you hit enter, you will see that there is asterisk and the / So this is long comment area. So anything that you put here is not going to be read by the compiler. So it's going to be ignored, which means just comments that we can add as we create our projects, right? So you can put some comments about what's the code doing and so forth. Commenting code is a very important aspect of programming because it allows you to remember at a later time what you wrote, let's say 2 weeks, 3, 4 weeks, or even months, or even years. But most importantly, it's also important for other people who may read your code. And yes, people actually read your code, okay? But it's also important to remember that comments are supposed to help you explain what's going on, not to write an essay, because we don't want to be those kind of programmers who excessively comment their code, because that is just not very helpful either, okay? So make sure that whenever you are writing code, you put comments that are meaningful to you, but most importantly to other people who are going to be reading your code. All right. Very good. So there we go. There is the distinction. So this is multi-line commenting, and this just one line commenting if you put 2 /. Okay, so I'm going to put that at the bottom. Let's give us some space there. Very good. So here I'm going to create a variable int a. It's going to be 12. I'm going to say int b is going to be 12 as well. Okay, notice that we have these 2 integers, these 2 variables. Now to add those 2 variables, I can say b plus a as such. Now we have a problem here because it's saying I don't know what that is. So that means we actually have to put that in a variable. So I can say int total is equal to that. Okay, very good. Now if I get rid of this int here, we're going to have a problem because again, whenever we create a variable in Java, we need to say what type it is. In this case, it's going to be int as such. Okay, very good. So now we can say sout. There is another shortcut you can do instead of typing in system.out, println. Now again, this is courtesy of this wonderful IDE, Android Studio that is. And if you just say sout, there's a few different souts here, right? System out. So I'm going to say sout, that prints a string from system out. If enter, and it writes all out for you. So I can say total like this. Save, as you know, run, we should be able to see 24 because indeed b plus a, which is 12 plus 12, is 24. Okay, there we go. So this is addition. Now, if you want to do subtraction, obviously, just put dash there, that's minus. If you save this, we should get 0, right? Because 12 minus 12 is indeed 0. Okay, very simple indeed. And of course we can, because this is a print line, we can add string here. So we can say in fact we have to put inside of a string, right? The total is plus like that. Okay, there is that distinction again. We said that this plus in this set here, in this sense, it is concatenation. It is not addition as we saw earlier. Right? Because if we save this, we're going to see the total is 0 because now it's taking this total that we got, right, from subtracting 12 by 12 or a or b minus a, and is concatenating it, gluing it with the string because it knows this is a string, so this cannot be, of course, an addition. However, if I get rid of this and say, for instance, 9, what do you think is going to happen? Save and run. It's going to say 9 because now it knows that this expression here, so whatever we're putting inside here is an expression in this case, right? It's going to say 9 plus You're going to say, well, total, it's also an integer, and 9, it's an integer. So this cannot be a concatenation. This has to be an addition, arithmetic. Very good. Well, what happens if I put that 9 inside like this? What do you think is going to happen? Save, run. You're going to say 90. But remember, this 90 here is not actually a number, right? Because what's happening here, it's still getting the total, which is 0. And because this is a string, it's being seen as a string and then a 0. Because we are, again, concatenating here. Because this is a string and this is not, it's an integer. Very, very, very interesting distinction here, right? So again, when we look at it, it looks like 90. Because it looks like 9 plus total, which is 0, is 90, which is not true, right? Mathematically speaking. 9 plus 0 is 90. But it looks like 90 because we have this as a string, which then makes this plus here as a concatenator. So it's gluing these two together so we can see it like this. Very good. So I'm going to go back to what we had before. The total is that. And also I can say Control R to run. Okay, and there we go. It's running perfectly. Very good. So we've learned so far subtraction and addition as such. Okay, so essentially they are minus and plus. So exactly what we've learned in school. Now, of course, we have subtraction. We can also multiply. Now, for multiplication, usually, mathematics speaking, we would have an x. But in Java, in many other programming language, we don't have that luxury. What we need to do is actually put an asterisk like that. This would mean that we have b times a, which is going to be the multiplication of b and a, which should be what, 144, I think. Run this. And it is, the total is 144. Very good. And then to divide those two numbers, all you have to do is just go like this. Divide as such, save, right? So it is indeed, as you see here, it is /, just the normal /. That would mean that we're dividing these two numbers. Hence, you say the total is 1 because 12 divided by 12, it is 1. Very good, very good, very good. Now, what happens if we say, for instance, this becomes a double like that? Well, we have a problem because now we say the total, we want the total to be an integer. It says required int found double. And there's a few things we can do here. We can come down here and it says cast to int. What cast means? Well, cast is saying we need to translate this number here so that it becomes the right type variable. Because again, Java is very sensitive when it comes to types. So here, if I go ahead and say cast to int, it goes ahead and casts this into int, meaning it takes this value here, which is going to be a double somehow, and makes it an integer, right? Actually, it's not somehow because I know we put this to be a double. So you can actually make this, or an integer, a double by just saying double. Of course, you can go ahead and put that 0 here. That's totally fine. It is indeed a double as well. But the moment you say this is a double, it is going to be considered by the compiler to be something like this, 12. That's 0 because it has a decimal point there. Okay, so there we go. So this is what's happening here. So we are transforming it, the double, and make it an integer. So you can actually make things, what we call casting them, into other types just to make sure that things work. So that is the beauty, okay? Because again, Java wants to make sure all the types are coherent and they make sense. You can't mix and match. You can translate them into other types, of course, as you can see here, by casting, right? But you can't just deliberately put a double into an integer and things be okay. As you saw, it always says something is not right and gives you suggestions on how to solve that problem. Okay, so let's save this. We're going to see that we are still going to see 1. Now, check this out. If I make this also a double, be double like that, notice I have no problem. Even though I still have this int here, if I save this and run again, we're going to see 1. However, if I get rid of this, I'm going to have a problem. But if I say now this double also, because it has to be a double, because we said A is double, B is double, so both have to be the same type in order for this total to actually work. Because the result of dividing double by a double has to be a double. Now, if you save this, look at the difference here. Say enter. Now, the total is 1.0, which makes sense because it is a double. Not just 1 now. it is precisely 1.0 because it has that decimal point there. Ah, very nice. You can see the differences now, right? So in this video, we were able to look at subtraction, addition, multiplication, and division, but also the distinctions between adding and multiplying, in this case, dividing dovetails and integers, and how to do a little casting here and there just to make sure that the types are correct. So I did this on purpose because I want to emphasize how important the types are in Java. In fact, that is one of the things that most people tend to dislike about Java, because it's strongly typed, meaning everything has to have a type, and otherwise things don't work. And even though this may sound like a curse, but it is also a blessing in so many ways, because everything is set to the way it's supposed to set. And the compiler will remind you, as you saw. Very good, very good. So without any further ado, I will see you in the next video.